Okay, so today we're going to be looking at correlation and what what the data will kind of be looking like. So here we've got this question that says correlation can be described by the type of function or graph that would best represent the trend of the data. Determine whether the correlation for each data set below is exponential, quadratic, or linear. Now, the first thing to notice about all of these is that the data is pretty well packed together. So for this first one, it's pretty clustered and going up like this. For the second one, they're pretty clustered and they're kind of got this kind of arch going down. For this last one, it is clustered a bit over here on the right side, and then it kind of slowly moves its way up into that. So, if we're trying to determine if it's like exponential, quadratic, or linear, we have to consider like what the graphs of those things look like. So, if we take a linear function, that would look like this, or like this, or like this. Some sort of line that's got a positive slope, a line with a negative slope, pretty much zero slope here. I tried to make it a flat line. Um, so here, we're going to look and see do any of them kind of resemble that. And right here, this first one, it does kind of look like it's going up in a line. So this one could be, the data could be modeled by a linear function. Okay, so now, well here, I'll put that back on there. So now, let's look at this guy. So, what we have left are quadratic and exponentials. Now, we know that neither of these are going to be linear because this one, it curves a bit, and lines are not going to be curving. That would be very odd. Likewise, this one, it starts off flat, kind of like a line, and then it just kind of shoots on up, which is, again, not like a line. So, the next type of thing is perhaps a quadratic. So those are parabolas that are either open up or open down, but they have this little arch to them. So this either, it's like you're going under a bridge or you got like a cup over here. Now, this one, it does resemble the second half of this guy, some sort of upside down parabola or some sort of upside down quadratic function. So this one could be modeled using a quadratic. Now, I know that leaves only exponential for this last one, so it's probably got to be exponential, but just to kind of talk about it a little bit, exponential functions look like this, where they start off slow and then they just shoot up and go off to infinity. Now, over here, what you are seeing is it starts slow and then it just shoots up. So that's exactly what we would expect from an exponential function. If you want to see an exponential function, some examples are like e to the x power. You could type that into Desmos, see what that gives you. You could type in like a 2 to the x power, something like that. That would give you examples of what exponential functions would look like. But that's how you know uh, the correlation for the data set, what it could be modeled by. Just you're just looking at, okay, what does the data look like? It looks kind of like a line. Looks kind of like it'd be a quadratic or a parabola. Looks kind of like the exponential function.